Welcome, class 221B. This is group 6. You're doing our lesson 14 group quiz. And David, this is the group quiz, not the homework quiz.
I got it this time.
Yeah. All right, let's get these.
Everyone have everything pulled up so we don't have to.
Yeah, I'm working on it.
Okay.
I have a computer folder of everything that we download for this class, and it's already over 50 files.
Yeah.
Yeah, we do a lot of files in here.
Ready for number 3 then?
Yep.
I'm there yet. Almost.
So this is true, correct?
I put true.
If I remember correctly, the null in this is the null is that there is no sufficient. So the null is that there's no difference between the means, and the alternative is because there's difference.
Mm-hmm.
Don't they have to be positive?
Yes.
I remember something about that. Does not need to be normally distributed.
Yes, no, they don't have to be normally distributed. They have to be.
Has to be simple random.
Well, no, yeah, they have to be normally distributed for each group.
Yeah, but like the ANOVA is not normally distributed. Okay, yeah, that makes sense.
The variances have to be equal. That's true.
Yeah.
So is that all of them?
Yep.
Seems like it.
No, I just need to see. You know that.
For question 5, would it be construct a QQ plot for each group?
Yeah.
That's how we check normal.
So number 6, we assume the variance in each group is the same if the following happens.
Would it be D?
D. Each group is no. It was like.
What was it?
It was if the largest variance is less than 4 times the smallest variance.
Okay, yeah.
Yep. Okay, an ANOVA hypothesis test is equivalent to conducting independent two-T tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1 to 2, 1 to 3, 2 to 3. How many pairs are there when there are 4 samples?
I'm just gonna use my fingers.
So it'd be 1 to 2, 1 to 3.
1 to 4, 2 to 2, 2 to 3, 2 to 4. Not 2 to 2. 2 to 3 and 2 to 4. That's 5. And 3 to 4. I think that's 6 then.
That's 1, 2, 3, 4, 5, 6. Yep.
Yeah, I think that makes sense.
I just did some foil style counting.
Okay.
I'll read this section. The data in soccer shoes was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacts the target to the center of the target. The smaller numbers are more accurate. All right. What is the minimum smallest variance for the 6 groups?
Okay, so we have to put all this in, right?
Yeah.
So we put A in one. We have
almost
A in the first one, B, C,
Yeah.
D. Right?
Yeah.
Now, if we were to rearrange the order, that wouldn't really affect our scores, would it?
No, but it would on. So if you read like what happened on our last one, like that's what we did is we went out of order, but that's just because it's like you're subtracting the two or whatever.
Yeah, that's why I asked, but it doesn't seem like it would on this. So.
Yeah, I don't think it would on here.
We're so silly. We forgot to put them in the right order.
Yeah, I think the order is more important on the independent samples than it is. Oh, and like dependent too, but I think it's more important in those than is the ANOVA. But I don't want to lose points for like not reading the question.
Exactly.
I'm on E right now, so.
You're fast.
I couldn't see the copy. I was like, oh, come on.
All right, folks.
Give me 1 second. I'll show my screen when I finish it.
So I'm pretty sure the smallest variance will be that 27.208 one, whenever you guys get there.
All right, I'm almost there.
Getting E right now.
Or 7.208, yeah.
I keep accidentally copying the Blake stuff.
Oh,
I meant to cook paste and it cooks copy instead.
You got to utilize that Command C, Command V. That makes it super quick.
I just right click on the mouse. All right, what's your lowest variance?
27.208.
Yeah, I got that too. That's group variable 3, which is C, right?
Yeah.
Yep. Okay. What is the maximum variance?
Maximum
53.158.
53.158, yep.
What was that? 53 point. What again?
158.
Okay.
Yeah, so 10 is true, correct?
Yeah.
The highest and the lowest are about half double apart. It's not like.
Yeah, it's not. It's less than 4 times.
Yeah.
So, yeah. See, the thing I don't like about this one is just so tedious because you have to like go through and like make a
1 second.
one of them.
Hello?
I don't remember. Okay, it's not that I don't remember. I just didn't see anything about a QQ plot. What is a QQ plot?
It was just like the plot that like told you, like it showed like if it like bent or anything like that to say if it was normally distributed or not. Let's see.
Can you see that on the Excel?
Yeah, you have to go to the quantitative descriptive statistics one.
Yeah.
So like from the unit 1 file.
And you got to enter each variable. This is, you're right, it's tedious.
And you have to do it for every single one of them.
Which ones are you entering into that?
All of them. You have to do them separately though, and like make sure each one of them is normally distributed. I think that's all you have to do. So I don't think you have to like save them because I don't think you get any information from it. You have to make sure they're, make sure each one of them are, whatever you want to call it, normally distributed.
All right.
I'm getting a weird. Let me pull it up for you. I'm getting something weird on my QQ plot for the first one.
Because you have to sort it from least to from lowest to highest, which I forgot how to do.
So the question here is that all these ones have openings in the beginning. How do I sort those?
Wait, so what were you saying? Or,
Look at my page. I'm getting something weird. I'm trying to figure out how to fix it.
Oh, so first, I think take them up to the number 2.
Yeah.
You know, it's like, hey,
Man.
Just copy and paste it, and then paste it into 2. Or do that, and then go over to filter or sort. Yeah, or I think it's filter actually. And then that should. Yours is weird.
Yeah, I have a different version of Excel, and I downloaded from BYU. Maybe it has to do with the fact it's a Mac.
Yeah, maybe. I don't know, because mine's showing that it's here. Do you want me to share my screen here?
Yeah, why don't you do that? I'll figure out somehow to get it work, but
All right, so can you see mine?
yeah.
All right, so this is what mine's showing here. So this is for the socks.
Okay.
So socks is normally distributed.
Yeah.
So then we have to go through and do. Come on. Do E. Yeah, it's normally distributed. My guess is they're going to all be normally distributed, but we should probably go through and do it.
Let me see if while you're doing that, I can figure out how to get mine to work.
All right. Wow, that one's like really straight.
Mine's weird because I can tell it's normally distributed, but it's doing something. Yeah, I'll have to check this out on my own time and see if I can figure out how to get it to work, because it clearly my Excel is different from your guys's.
All right, I'm almost done with this. Would you say that's pretty normally distributed?
I'm not sure. I would think so, but
I think so. All right.
yeah, that's normal, dude. No worries there.
One more. Come on. right, yeah, they're all normally distributed.
All right, so
The next one's 0.309.
So hold on a second. So it's true, and then the p-value you said was point what?
309. All I did was just erase the variable 6
yeah,
value over.
Sorry, what was that number again?
all right, 0.309. I'm share screening it. I think so.
Yep, you are.
And then 13 is right, correct? Because it's right skewed.
They always have to be.
Yeah.
Okay.
Now we got to do the whole thing over again for the next one.
Oh, yeah, I'll read
Yeah,
it.
so these ones are tedious, man. I'm telling you.
Yeah, I know.
Researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, meat. Mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in the file, blah, 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 blah. Use this data file to answer the remaining questions.
Let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and comparative variances to determine if the assumptions used ANOVA have been met.
Okay, so we're doing calories first.
Yeah.
I'll do the calories for the poultry meat.
Well, we have to do them all in the same one. So yeah.
So we're doing
It's
calories
offer, but
first.
is this
Only calories, right?
yeah, only calories. We're gonna do sodium later, I'm guessing.
This is so yummy. Looking at these numbers.
Making me hungry.
Yeah.
There's not the same. There's not the same number of them. That's right, correct?
Yeah, that's correct. The sample size is different for each of them.
Okay, so and there's only 3 variables. So what's the question? Let's examine the calories first. Construct QQ plots for the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met.
I'll read the answers. The assumptions have been met. It's safe to assume each group comes from a normally distributed population from QQ plots, and we also assume the variance are equal.
Here, let me do the QQ plots, and then we can get that.
All right, you do that. The variances look good here, so let's just do the QQ plots.
Variances do seem like they fit.
Yeah, so the lowest variance is 508.566. The highest is 636.846.
All right.
So they're not far apart.
So variable 3 is good. Let me get variable 2 in there. Oh, crap. Three. Variable 2.
Do they really have the same variances?
The variances aren't the same, but they're
Close.
so like we assume they're the same if they're the largest one is within is no more than 4 times greater than the smallest one.
Okay, that's right. Okay, I was thinking of like multiplying one of the variables, and so that's what. But no, that makes sense. Okay.
All right, let's see here. Okay, they're all pretty normal. So,
We're safe to do number 1 then.
Yep.
Alright. Alright, 15. Run a NOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. To find degrees of freedom are 2 and 51. That F equals 16.074. That P equals 0.00. So level significance equal to 0.05. What conclusion can you draw?
wait, so those are the numbers we should have?
Yeah, I'm checking those right now.
I got them.
What's your
That-
P value?
0.000.
Okay, that's weird.
I mean, it's what 3.86207 times 10 to the negative 6.
Oh, okay. Yeah. So my screen's not pulling all the way out. Okay, I see that you just said okay.
Because that's what I got wrong on my homework quiz. I was trying to figure it out because I did it twice and like I got that p value, but I was like, how do you put that in? And I guess that's what they want is 0.000.
Yeah, you know what? I freaking messed that up. That was the only one I got wrong because I recalculated something. I was like, whatever. I'm just gonna put it in.
And I emailed him after the first time and I was like, can you explain this to me? He's like, no, you got it. Just like try it again. I tried it again. I didn't get it, but now I get it. Like,
Yeah.
yeah. Okay, I got all those numbers too. So,
All right, then
Let's see.
would it be A again?
we have sufficient evidence to claim that all 3 hot dog types have the same mean number of calories. No, because aren't we going to reject the null hypothesis?
That's
Yeah,
right.
it's-
Okay, sorry.
So we do not have sufficient evidence to reject the claim. No, that's not it. We have sufficient evidence to claim that all 3 hot dog types have a different mean number of calories. I think that's the one.
Yeah, that sounds right to me. All right, sodium time.
So the answer is D.
Yeah. Or C. Answer is C because what happens is like our p value was 0.000, which is less than 0.05. So we reject the null hypothesis. All right. I'll go ahead and enter the sodium ones into the QQ plots and get that figured out.
All right, I'll work on the.
I'm assuming he's not going to give us one that's not normal, but might as well.
Well, like when you're doing, if you're in a profession where you're actually doing this on a real data, you're gonna get a normal ones.
Yeah.
Dave, do you mind sharing your screen with us just so we can see how you do it?
The QQ plots?
Or like, yeah, whatever you're doing, just because I think I'm not really following how you're getting all this number stuff. I just wanted to see how you do it.
So the numbers, I think Brooks is doing that part.
Yeah. Let me pull up the.
All I'm doing is I'm putting it into the QQ plot, and it's telling me whether it's normal or not. So basically, if it's like it follows,
Oh,
Yeah, I'm running the Excel on whether the ANOVA.
Okay.
oh, that's all you do. Just copy and paste.
Okay, I'm gonna start reading through the answers. Now examine the sodium levels. So it says that Davis. It says that it shouldn't be normal in one of them.
Really? Okay.
Yeah. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 7180.
With poultry?
Yeah. 10,492. Okay. Have the assumptions been met to use the ANOVA? No.
Yeah, so I'm getting the same variances that they list. So that's correct. Let me know, Davis, what you see for that poultry thing. And if you can share screen it.
Oh, yeah. I mean, I guess
Let's see it.
It's pretty. I don't know. It's pretty like you just kind of. I don't know what to think about it here. Yeah.
It's all subjective.
Yeah, it's very subjective. That's what I got.
Yeah, I
Yeah.
can see because there's sort of a weird.
It's like curves. Yeah. So yeah, I'd agree.
Well, the other thing too is the sample size is also small. So if our sample size is larger than 30, it wouldn't matter, right?
Yeah.
Yeah, maybe.
Because I don't know about the central limit theorem. Is if the sample size is larger than 30, would the QQ plot look better?
I'm pretty sure that's what the law is. That sounds right to me. The only problem I'm seeing now is with these answers, it doesn't give us that option. It only gives us the option that both the variances are not equal and that it's not normally distributed. It doesn't give us just the option to say that they're not distributed evenly, but I don't know if...
Yeah, see. So the assumption after that is not safe to assume each group comes from a normally distributed population, but we can assume the variances are equal.
Perfect.
Does it look good to you, Camden?
Well, what are you saying? Are you saying D then?
C.
C. It is not safe to assume each group comes from a normally distributed population, but we can assume the variances are equal.
I misread that because I was, yeah, okay, all right, I misled that. I thought it was the other way around, saying that they are evenly distributed or normally distributed, but they're not equal variances. So, okay, that's good.
All right, so I will pop up my...
All right, so despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all three groups. What is the p-value for this test?
You seeing it on my screen?
Yeah, so 0.179.
Yeah.
We do not have sufficient evidence to reject the claim.
Yeah, because what was our level of significance?
It's 0.05.
Oh, yeah, 0.05, yeah.
So it's B.
Yeah.
We do not have sufficient evidence to reject the claim that all three hot dogs have the same. Yeah. All right, I'll submit it, see what happens. Okay, so for 4, we got 0.67 out of 1. So we must have just clicked one that wasn't.
Was it the sample means they're all positive, I guess?
Yeah.
Man,
Yeah, because I don't have that
reading about that, but
I think that was for something else.
yeah.
Yeah, I don't see that in my notes. So
Okay. So, but
I know what the problem is. The ANOVA has to all be positive. The ANOVA graph has to all be positive. There can't be negative on the ANOVA.
Makes sense.
I just got confused. That's the only problem then, Davis?
The only other problem we have is 15.
Let me pull it up.
Because it's D, not C.
Oh.
We have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type. Not all three of them.
Yeah, that makes sense.
why just one?
Because this is yeah, I don't know.
It has to do with the nature of the ANOVA test.
Okay, that makes sense though. I mean, it does. I just
Because we're looking at the variance differences, but we can't, you would have to go, you have to do other tests to confirm which variance is different. You know what I'm saying? So like we are looking at the, essentially, the NOVA is looking at the difference between the means between them as a group and between each other. And so it doesn't specify which one is different.
Here, does someone want to keep that open and talk me through those answers again so I can get those?
Yeah, mine is share screen, right?
Hold hold on a second.
Let me check.
Let me pull this up again. True. True.
All right. Let me know when you want me to scroll down.
All right. So 3 is true.
4 is B and C.
4 is B and C. 5 is C. 6 is, what was 6? Sorry, B.
Yeah, I got it up here for you so you can look at that.
Okay.
7 is 6.
6. So I have to like go back and forth to my screens because they're both pulled up on the same browser.
Yeah. 8 is 27.208.
Okay. 9.
53.158.
3.158. 10.
True.
10 true.
11 true.
11 true.
12 is 0.309.
Okay, 13 was right.
Yeah.
14 was
A,
A.
I believe. 15 we changed to D.
15, yes, D. 16 was
C.
C. And what was 17?
0.179.
9. A. And
18
then
D.
B. All right.
I'm going to submit it this time, make sure we got it right.
Okay.
I don't want you to lose your chance. All right, got 100. Does everyone have the same stuff?
Let me, I'm submitting mine right now. Yep, I got 100.
All right, how about you, Davis?
Yep.
You okay, Spencer?
Yep.
All right, then I think this meeting should be adjourned.
Pretty good. Pretty straightforward. Does everybody understand what's going on? I mean,
Yeah, basically, it what it's simply doing is looking at different, not just 2 samples, but multiple, and then we're looking at the difference between the 2. Pretty straightforward. All right, I'm going to start the broadcast now.